We thought we knew, but light revealed the truth. "Let there be light," said an ancient voice, and since then, we sought the truth of what it was. Every time we thought we knew, light changed the way we saw reality itself. We looked, formed elaborate theories, and believed them. But every time we thought we knew, light showed us the truth. The ancient Egyptians believed that light came from the sun god Ra. The Greek philosopher Euclid believed we ourselves were the source of sight. He proposed that our eyes emitted rays to sense the world, casting the observer as the projector of reality. Though incorrect, Euclid did realize that light travels in straight lines, a fact that endured. Ibn al-Haytham, who lived 1,000 years after Euclid, was finally the one to challenge his authority. He declared that the true seeker of truth was the one who did not blindly trust the writings of the ancients. He created the first pinhole camera, which proved that light was what formed images even when our eyes weren't involved. The world we perceived was delivered by light, and we were merely the observers. We thought we knew, but light showed us the truth. The question then shifted to the nature of light itself. For centuries, rooted in the philosophy of Aristotle, it was assumed that white light was pure and perfect, while color was an impurity added by the medium it traveled through. As Johann Wolfgang von Goethe later described the prevailing view, color is a sickness of the light. Isaac Newton shattered this vision. With 2 glass prisms, Newton showed that white light was not pure and singular, but was a mixture of all colors. Colors were not created by the prism, but were fundamental properties that existed within light. This discovery led directly to spectroscopy, which allows us to study the precise bands of colors that stars emit, telling us what they are composed of. Light did not just carry images, but detailed facts across astronomical distances. We thought we knew, but light showed us the truth. Yet, the nature of light still remained an unknown. In his book Optics, Newton said light was made of tiny particles that reflected and diffused. And everyone believed Newton, the father of classical physics. How could Newton be wrong? Was the prevailing sentiment for 100 years, despite rival theories. Thomas Young proved him wrong with his famous double-slit experiment. By passing light through 2 tiny openings, he showed that the light spread out and overlapped, creating dark and bright bands called interference patterns. This behavior is only possible if light is acting as a continuous, expanding wave, not tiny particles. We thought we knew, but light showed us the truth. But light held a last secret. Heinrich Hertz noticed that ultraviolet light caused sparks to jump between metal electrodes. But failure to explain how light makes metal surfaces emit electrons meant the wave theory failed too. Albert Einstein and Max Planck solved this problem by declaring that light must arrive in discrete packets of energy called photons. This meant light was not one thing, but 2, a wave and a particle at the same time. It seemed that light behaves differently if we look at it in different ways. This dramatic change is a powerful example of the observer effect, proving that light's nature is fundamentally dependent on how we choose to question it. Heisenberg described this by saying, "What we observe is not nature in itself, but nature exposed to our method of questioning." This was the moment reality proved contradictory, opening the entire world of quantum physics. We thought we knew, but light showed us the truth. At age 16, Einstein imagined what it would be like to move through space at the speed of a beam of light. Would light appear to be static? Amidst all the profound quantum confusion, where light seemed to change its very nature based on how we looked at it, experiments proved that one property remained stubbornly, universally constant: its speed. It was never static, nor did it slow down. Einstein, realizing that the speed of light must remain the same for every observer, no matter how fast they were moving, was forced to a profound and inescapable conclusion: to protect light's speed as the ultimate constant. Space and time could no longer be separate or absolute, but had to be unified into a single flexible fabric called space-time. We thought we knew, but light showed us the truth. Einstein also realized that light is the fastest thing that exists, and nothing can exceed its speed. This cosmic speed limit dictates the boundaries of our observable universe. Because light takes time to travel, we can only see objects whose light has had time to reach us. We can never look beyond what light allows us to see. The farther we look with telescopes, the further back in time we see. But we can't see the beginning of the universe, because light as we know it did not really exist. Light has taught us that we cannot know everything, and whatever we know depends on how we look at something. It has guided us from ancient faith to certainty, to further uncertainty, and finally to the profound acceptance that knowledge has its limits. The ultimate lesson light offered was humility. We thought we knew, but light showed us the truth.